Hey guys, my name is Confident. Welcome to the 24-minute lesson excerpt where I will be sharing with you some ideas, some methods, some strategies or concepts that you can incorporate as you prepare for your final exams, be it you're studying for your Mathematics N1, your N2 or your N3. Now, if these videos are handy and you are benefiting from them, you can actually press the like button, or if you've got some ideas, you can leave some comments below. If you also like to be notified of extra videos every time we post them, you can subscribe to our channel and then you'll get some notification every time there are new videos. And also, if you are interested in some of our resources, be it textbooks and some videos, you can check this at the end of this video. We will send you some information. Now let's check this concept out. Exponential equations are the most important part of your Mathematics N2, and these usually become Mathematics N3, and you also find same exponential equations in your Mathematics N4. So if you're going to be doing your Mathematics N1, your Mathematics N2, N3 and N4, this is a good foundation for you to see how these equations later change into N3 and N4. Now let us look at the question that is given here. This is a previous question paper. This is a question taken from the previous paper. It says 3 times, that dot there is times. So 3 times 2 to the exponent x is equal to 24. So the question is, we need to solve for x. So as I say, it is exponential equations. So how do you go about in simplifying this kind of a problem? So what we have in this case, if we can take we need to take care of these 3 here. So the first thing that is important for you to do is to divide this expression by 3 so that you can remain with 2 exponent x. But what you do on the left hand side, you have to do on the right hand side. So that is how you are going to in this case, it is cancelling the 3 to cancel the 3. Now 3 into 24, you will get the 8. So it is how you are going then to remain with 2 exponent x is equal to 8. So you see, this is how the whole challenge was. It was this particular 3 which was complicating everything. Now when you have got this, you are left with 8. Now you have to write 8 in terms of 2, and the main aim is for you to match the exponents. Remember, we have a law in exponential equations which says if a to the power of x is equal to a to the power of y. So what we have got same base. This is the base is a, and the base is a on the left and the right hand side. Now it means we can conclude and say, therefore we equate the exponents, whereby we say x is equal to y. So this is what we want to achieve also on our problem. Now with our calculator here, we can see that 2 times 2 times 2 is equal to 8. So it means 2 to the exponent 3 in this case is equal to 8. So we can write 8 in terms of 2, which is 2 to the exponent x is equal to 2 to the exponent 3. So we have managed to match the bases, and therefore we can conclude also in this case and say, with that, therefore x is equal to 3. So we equate the exponents and we have solved for the value of x. So that is how you are able to solve the value of x in that case. Now you can quickly prove your answer in this case. If we can say proof, just to check if you're correct. So we are given 3 dot 2 to the exponent x is equal to 24. So I know my value of x. Remember, my x now is equal to 3. I got the value of x as 3. So I'll do with 3 dot 2 to the power of 3. It must give me 24. So if I check with my calculator and say 3 dot means times 2 to the exponent 3, this is equal to 24. You can see that. So 24 on the left hand side, it balances with 24 on the right hand side. Therefore, left hand side is equal to right hand side. When it's like that, it means my value for x is equal to 3. Therefore, it is correct. So that is how you can approach exponential equations as the foundation of these. As I said later, you find the same questions, though at an N3 level as well as N4 level. I hope this was of benefit to you. Remember, if you want to be notified of these lessons, you can subscribe to our channel by pressing the subscribe button, or you can also if ever you want to make some comment, you can also like or leave some comment for us. Thank you. Solving your exponential equations for mathematics N3 is also an important aspect of your studies, and in this particular short lesson, I brought you a typical exam question that involves some exponential equations. And then if we look at the question, it says we need to solve for x, and we're given some exponents, which is 2 to the exponent that and 2 to the exponent that, and then we've got 2 to the exponent negative x. This is equal to 42. So now the question is, how do you approach such questions in your final exam? Now, the first thing that you need to do is to use the first law of exponents. Remember, you are given that the first law of exponents, it says a to the power of x times a to the power of y is equal to a to the power of x plus y. So this is the law which we are using. In this case, it says when the bases are the same, and then there is a multiplication sign between the two exponents, then you add the exponents. Now, if I can write the same law from left to right, in this case, in this direction, what I'll be having is, I'll be having a to the power x plus y is equal to, therefore, I'm going to split this x plus y exponent to give me a to the power of x times a to the power of y. So this is basically the same law number 1, but written from from right to left. It is this way of writing the law which I'm going to use in my equation. So I'm given 2 to the power x plus 2. It will become 2 to the power x times, in this case, 2 to the power of 2 plus, I use the same law again, 2 to the power of x times 2 to the power negative 2, and then plus. Now this is another law that I'm going to use. In this particular case, I'm given, there is a law which says 1 over a to the power m is equal to a to the power negative m. So now you can see that for me to get rid of the division sign, which is this part, the 1 over, I must put a negative so that it will remove the 1 over. So if I can use the same thing, the fraction 1 over 2 is the same as, in this case, if I say 1 over 2, it is same as saying, if I want to get rid of this part, I can simply say there is a power 1 there, which is 2 to the power negative 1. So that is the first part. The second part again, if you are given in the laws of exponents, if you are given a to the power of m, and then you have got a bracket and there is an n, it means the two exponents must multiply to give you a to the power m times n. So These are the two laws that we'll be using, such that if I take it from here, if I'm given in this case 2 to the power negative 1, and then I multiply that times negative x, it can simply become 2 to the power minus 1 times minus x, which is equal to 2. Negative and negative will give you a positive, so it gives you 2 to the exponent x. So in this case, I'll be having here also 2 to the power negative 1 bracket negative x is equal to 42. So when I've done that, you can see that, as I said, I can write it now to say this is 2 to the power of x. The times can be written as a dot, 2 to the power of 2 plus 2 to the power of x dot 2 to the power of negative 2 plus a negative, and a negative will give me 2 to the power of x, or 2 to the exponent x. This gives me a 42. Now your calculator will come handy in this case. What you have to do now, the next stage here, you need to factorize. So we're going to factor, in this case, we are going to factor 2 to the exponent x. As you can see, it is common, it is common, it is common. So if I factor out 2 to the exponent x, what will remain inside the brackets will be 2 to the exponent 2 plus 2 to the exponent negative 2 plus 1, because when I divide 2 to the exponent x divided by 2 to the exponent x, remember there is a 1 that is going to remain here. Most of the students will say nothing, but there is a 1 because you're dividing. In this case, you are saying 2 to the exponent x over 2 to the exponent x. If you cancel, you are left with 1. So that this will equate to 42. And then after that, what you have is you need to take your calculator then, and then you add everything that is inside the bracket to say 2 to the exponent 2 plus 2 to the exponent negative 2 plus 1. And then if you add that negative 2, and then it's plus 1, and then you're going to get 21 over 4. So you have got 2 to the exponent x times 21 over 4 is equal to 42. So at this stage, you also have to now you are simplifying your algebra here. You can choose to divide both sides by 21 over 2 here, over 4, and then I also can divide both sides by 21 over 4, or you can multiply by 4 over 21, or this one by 4 over 21. It is up to you. Whatever way you're going to do, the answer will always be the same. So whether you multiply or you divide, you will still get the same answer. So I choose to divide in this case. So now if I divide, so I'll be left now with 2 to the exponent x is equal to, again, use your calculator more handy. So you are saying 42. Be careful how you divide it though. So you have your fraction, that's where you've got your 42. You have to play down, and it is at the bottom that you have another fraction, which is 21 over 4. And then your answer becomes 8. So as a caution, avoid entering like some, they put a division sign and another division sign immediately, such that it will be 42 over 21 over over 4, and your answer will be totally different. It's giving you 1 over 2. So what you must do is you must have your 42, you play down, and that's where you have your fraction, and then it's your 21 over 4, and then it will give you your 8. Now when you've got your 8, the aim now is to express 8 also in terms of 2, and then you can remember that 2 to the exponent 3, this is equal to 8. So this would be the same as saying 2 to the exponent x is equal to 2 to the exponent 3. And if you remember, we have an exponential equation law which says a to the power of x is equal to a to the power of y. So if the bases are the same, you equate the exponents, it means x is equal to y. So in the same way, it also means the bases are the same, therefore x is equal to 3. So that is how we can solve for x in that exponential equation. Now with our x is equal to 3, we can actually prove our answer. Remember here we're saying where there is x, we are putting a 3 here, and then where there is x, we put a 3. So we do that, and then we do that. So whatever there is an x, we put a 3. If you test your answer, it must equate to 42, which is 2 to the exponent 3 plus 2, and then plus 2 to the exponent 3 minus 2, and then plus in bracket, it's 1 over 2 to the exponent negative 3. So that's what you are having. Whenever there was an x, I substituted with a 3. If you say equal to, you can see that it is also giving me 42. Therefore, it means my value or my answer for x in that particular instance, it is correct. So you can actually mark yourself without having to rely on whether the examiners got it right, or they check whether you got it right or wrong. You can yourself check if ever your answer was correct, and you can leave that exam room knowing that that particular question you managed to nail it. I hope this was of benefit to you. If you benefited from the lesson, I will encourage you to leave a comment or press the like button. And if you want to be notified of future videos, you can subscribe to our channel by pressing the subscription channel. We've come to the end of our lesson. Thank you. Solving of exponential equations starts from your mathematics N2. It grows into N3, and then lastly, you can also find, not last as such, but you also find these exponential equations in your mathematics N4. For example, this is an example from a previous paper. It says you need to solve for x, and what you're given here is 5 to the exponent that is equal to 7 to the exponent that. So that's why we call these exponential equations, because they are equations that involve exponents. Now, how do you approach these at your mathematics N4 level? Now, the first part that you need to recognize is the bases are different. Now we have got 5 here and the base here is 7. And then the most important thing there is to introduce ln. So what you do, you just write your ln to say ln 5 to the power 2x minus 1 is equal to ln 7 to the power 3x plus 4. And by the way, in as much as I say you can introduce ln, some people want to work with logs. You can also introduce logs to say log 5 to the power 2x minus 1 is equal to log 7 to the power 3x plus 4. Whatever way you choose, it will always be the same answer. And then with that, what we need at this stage to do, we are using the laws of logarithms, in which when you've got the power and the power drops down such that you will have your 2x minus 1 dropping down and then remaining with ln 5, and now this must be always in brackets. So that is how you use your ln. Same thing, and you'll be having also 3x plus 4 dropping down, and then you'll be having ln 7. So that is how the whole concept of introducing logs changes the exponent to drop down so that it becomes linear. At that stage, you can now expand, and then you're expanding that and that. Same thing here, you're expanding that and that. So you're opening bracket, so that is ln 5 times 2x. You have got 2x ln 5 minus ln 5, which is 1 times ln 5, is equal to 3x ln 7 plus 4 ln 7. And then what you need to do there is to collect your like terms such that this goes to the other side and this goes to the other side, and you are having your 2x ln 5 in this case, and then minus 3x and ln 7 is equal to 4 ln 7, and then it becomes plus ln 5. So it is that which you are having, and what you need to do in this case, you can actually factorize x there to say x is common, and then you've got 2 ln 5 minus 3 ln 7 is equal to 4 ln 7 plus ln 5. And then remember, you're simplifying, you're solving for x. You can divide by your 2 ln 5 minus 3 ln 7. Again, your 2 ln 5 minus 3 ln 7. And then when you do that to cancel, you are then going to have your x is equal to, and in this case definitely you need your calculator to say this is 4 ln, there is your ln 7. When it opens the bracket, remember to close it, plus ln 5, and then you've got your 2 at the bottom, ln 5, and then minus 3 ln 7. So this is what we have, and then we write our answer, which is minus 3,5867. If I want to leave it in 3 decimal places, you say shift, your calculator can round out for you, you press 6 there, and then to 3 decimal places, which is minus 3,587. This is rounded off to 3 decimal places. Now with all the values of x, you can always prove if your answer is correct. So where there is an x here, we can actually use our minus 3,587, and then even here you can use minus 3,587. Let's try to prove and see if ever we are getting something that proves that our x is correct. So we are saying on the left hand side, it's 5 to the exponent 2 times minus 3,587. Now remember, this is the rounded off, so it won't give you the exact values, but it will give you some answers which are different with a few decimal places. So with that, if you say equal to, you see I'm getting 1,934. It's 1,935 times 10 to the power negative 6. So it's 1,935 times 10 to the power negative 6. I'm getting it on the left hand side. Let's try the right hand side. again, just so that we can see it clearly. 7 to the exponent 3, and then it's, in this case, it is minus 3,587, and then it's plus 4. If you do that, okay, again it's 1,933 times 10 to the power negative 6. You can see this one now gives me 1,933 times 10 to the power negative 6. You can see that these answers are almost the same. They are the difference is very small. It means, therefore, your value of x is correct. So that is how you should have solved it. Some people, in this case, just to say, they prefer to convert ln 5 from this point. They find the value of ln 5 to say here. They are given ln 5 is equal to, they say 1,609. So they will change already here to have 1,609, and they find ln 7, and with ln 7 it will give them 1,9459, which is 1,946 here. 1,946. So that now when they expand, already they're expanding a number, and then when they expand there, they're expanding a number. So it becomes easier to solve for x because already you would have converted that. So it is another way that you could have used. It's still fine, but at the end of the day, it will take you back to your answer as x is equal to minus 3,587. I hope this was of benefit to you. Remember to subscribe to our channel if you want to be notified of some future lessons that we're going to post in your Mathematics N4. Or alternatively, also, if you want to leave us a comment, feel free to leave us a comment. Or if there's some sections that you want me to cover for you and you've been struggling with, feel free, and I will be willing to help with gladness. Thank you. I hope the video that you just watched was of benefit to you. And as I said, if you benefited from the video, you can press the like button, or you can leave us a comment below. And if you want to be notified of these videos, you can always subscribe to our channel. Now, if you want the full curriculum of this mathematics, if you're studying for Mathematics N1, N2, or N3, and you want the test book as well as the videos, we have a full curriculum of the Mathematics N1, N2, N3, as well as the accompanying videos. We also have videos of the previous question papers, the latest papers that were written in video form. These question papers can assist you as you prepare for your exams. We also have PDF version of the previous question papers that were written since 2014 until now. And if you want them, you can check all the information from our website, and trust me, these will become very handy to you. We sell them at a very discounted prices, and it is worth the try. Thank you.